Welcome to Study Loop.
This is the answer to Chapter 13, problem number 33 from the Smith Organic Chemistry textbook. And in this problem, we are given 4 sets of data and asked to draw a molecule consistent with each set of data. So for A, we're asked to draw a molecule that contains a benzene ring and has a molecular ion at M to Z 107. And so that 107 is a clue. An odd number for a molecular ion often indicates the presence of a nitrogen. And so I'm going to move forward with the assumption here that we have a nitrogen in this molecule. And so benzene is worth 78, but if we make it a mono-substituted benzene, that's going to be worth 77. And so if we, so 77, so we need to account for 30 more. And one of them has to be a nitrogen. So let's add a methylene group. So that's going to add 14 for us. And so that will take us to 91. And then we need to add 16 more, which is easily accomplished with an NH2 group, primary amine. So that will add 16 for us. And so that equals 107. Okay, and so we've proposed a consistent structure for A. And so that's sort of the methodology that I'm going to use here. Whatever the problem gives us, we'll just work with and sort of fill in what we need to hit the target number. So for B, B is a hydrocarbon that contains only sp3 hybridized carbons and a molecular ion at M to Z 84. Okay, so a hydrocarbon, only sp3 hybridized carbons, and a molecular ion at M to Z 84. So let's see. So we're told hydrocarbon, and we're told M to Z equals 84. So that's not a lot to go on, but we can start guessing at a molecular formula from this. So M to Z equals 84. So 8 carbons would be 96. 7 carbons would be 84 exactly. We're not going to have a molecule that's just carbon. So let's go one less. So let's go 6 carbons, which is going to be worth 72. So then we will have to have 12 hydrogens to make up the remaining 12 that we need. And so we can do a quick HDI here for C6H12. HDI is going to be 2 times 6 plus 2 minus 12, all of that over 2. So 14 minus 12 is 2 over 2 equals 1. Okay. So the only way that I can see to do this, well, no, not the only way, but a simple way to do this is to just make cyclohexane. So that's going to give us 1 degree of unsaturation. It's going to be 6 carbons and 12 hydrogens, and it's going to give us a molecular ion at 84. So that's a simple solution there. Okay, and so moving on to C. A compound that contains a carbonyl group and gives a molecular ion at M to Z equals 114. So for C, we know we need a carbonyl. And we know we need an M to Z of 114. Okay, and so again, this isn't too terribly much to work with, but we know that we're going to have 1 oxygen. So 1 oxygen, at least 1 oxygen, right? But so 1 oxygen would be worth 16, which is going to give us, so let me do it this way then. So we have 114. We can get rid of 16 for the oxygen. That's going to leave us with 98. So then we can think about numbers of carbons. So let's do 7 carbons. So 7 carbons is going to be 84. And so that's going to leave us with 14 hydrogens. So the formula that I'm going to propose here is going to be C7H14O. Okay. And so again, we can calculate a quick HDI here. So it's going to be 2 times 7 plus 2 minus 14 over 2. It's going to be 16 minus 14 is 2 over 2 equals 1. So the only double bond that we're going to have here is our carbonyl. So let's draw a heptane chain, 1, 2, 3, 4, 5, 6, 7. And let's throw a ketone in there pretty much wherever we want. We could do an aldehyde. We could put the ketone elsewhere. I'm just doing it there because it's nice and in the middle. Yeah, and so that's going to fulfill all of our requirements for C. Okay, and then so lastly, D. So for D, we're told to make a compound that contains carbon, hydrogen, nitrogen, and oxygen and has an exact mass for the molecular ion at 101.0841. Okay, so let's see here. Okay, so let's write our information as I have before. So carbon, hydrogen, oxygen, nitrogen, exact mass is going to be 101.0841. Okay. Okay. So we can really approach this similarly to how we've approached this before. So just give me a second because I'm going to have to get back to that table in the chapter that lists the exact weights of things because that will come in very handy here. Okay. All right. There we go. Okay, so table 13.1, I have it on page 492 of the textbook. So table 13.1 lists the exact masses of common isotopes of carbon, hydrogen, oxygen, and nitrogen. So nitrogen is going to be worth 14.0031. And so we have an odd number here, 101. So we know that we're probably going to have one nitrogen. So one nitrogen is going to be worth, what did I say, 14.0031. Okay, and so that's going to leave us with 87.0810. Okay, so let's see what else we might have here. So let's assume that we have a single oxygen. So that's going to be worth 15.9949. 0.9949. And give me one moment to actually do the math here. Okay, so 87.0810 minus 15.9949 is going to be 71.0861. Okay, and so now we should think about carbons and hydrogens. So 71.0861. Okay, so carbon is worth 12 exactly. So let's say, for argument's sake, that we had 60, so 5 carbons, which would be worth 60. So let's go C5. That's going to leave roughly 11 H's. And then we said 1 nitrogen and 1 oxygen. Okay, and so we could do the math here. So nitrogen, so hydrogen is worth 1.00783. So times 11, it's going to be 11.08613. And then what did we have left? We had, okay, good. So that's perfect. So then plus 60 for carbon, and then plus 15.9949 for the oxygen, and plus 14.0031 for the nitrogen is going to be 101.08413. So that is perfect. So this formula is perfect. We now just need to draw something that's going to incorporate all of these pieces. And we should probably start again with getting an HDI because it tells us exactly how many double bonds or rings we're going to have. And so this is going to be 2 times the number of carbons. Oops. So this is going to be 2 times the number of carbons plus 2 minus the number of hydrogens. So in this case, because we have 1 nitrogen, we need to add 1. So it's plus the number of nitrogens. And so that is going to get us to 12 minus 11 plus 1 is 2 over 2 is 1. So we have 1 ring or 1 double bond here. And so to make this easy and incorporate the oxygen and the nitrogen, I'm just going to draw an amide. And so that's going to look like this. So we can just put it right here. So an H, and then how many more carbons to account for? 3 more carbons. So 1, 2, 3. So there we go. There's an amide. And that certainly fits the data that we were given for part D. Yeah, and so that's the answer to this problem. That's the way that I would approach it. Just use what you're given to try to derive a formula. Once you've derived a formula, find the HDI, and then draw something that fits your formula, fits your HDI, and that will give you the molecular ion that you're looking for. And that's the answer to chapter 13, problem number 33.